further sketching of absolute values. So here we're going to look at 3 types of absolute value functions that we can sketch. So given a curve y equals f of x, we're going to look at sketching y equals the absolute value of f of x, y equals the f of the absolute value of x, and the absolute value of y equals f of x. So the curve we're going to look at is y equals x minus 2 squared minus 2. Let's go ahead and sketch this. So this is just going to be a parabola shifted to the right by 2 and then down by 2. And its y-intercept is just going to be at 2 because we're going to get minus 2 squared, which is 4, and 4 minus 2 is 2. So we're going to get going through 2. This is 2. This is minus 2. And we're going to get something like this parabola here for our original function y equals f of x. So first we're going to look at y equals the absolute value of f of x. This is probably the easiest one to sketch because what it's saying is that y can never be negative because we're taking all the y values and absolute valuing them, which means that all of these y values that are negative, we just absolute, so the absolute value of these positive y values will be identical, but the absolute value of these y values end up being positive and get reflected about the x-axis. So the sketch for this one is going to look something like this. So that's fine, still going through 2, and this part is the same, but anything below the x-axis gets flipped up and reflected. So we get that for our function. So some rules here we can say is that we can keep all that's above the x-axis and we're reflecting y values, reflecting negative y values about the x-axis. Okay, what about y equals the f of the absolute value of x? Well, it's kind of similar since we do have the absolute value, but what it's saying is when we have the absolute value of x, any negative x values are going to behave in the exact same way as the positive x values. So all of these positive x values will also behave in the exact same way as the negative x values. So what we want to do is we want to keep all of our positive x values exactly the same because they won't be affected by the absolute value of x, but all our negative x values, they want to behave in the same way as these. So essentially we're keeping everything on the right of the y-axis and we're reflecting it about the y-axis. So for this one we're going to get the parabola here acting on the right and then reflecting it about the y-axis and getting something like that. So we want to keep, so the rules are is keep everything on the right of the y-axis and delete what's on the left of the y-axis and then reflect about the y-axis. And finally, we have the absolute value of y equals f of x. It's probably the trickiest one to draw out of them all. And one way to think about it is that the absolute value can be thought of plus or minus y equals f of x, because that's our definition for an absolute value. But since we have the absolute value of y, we can never have any negative values for y because we're always absolute valuing it. So anything below the x-axis where we have negative y values will actually not exist. So the first thing we can do is go ahead and draw our positive y values in. This is going through 2. And because we have this plus or minus definition for y, all of those positive y values, we just get their negative y value counterparts. So we end up getting a reflection about the x-axis. That's going through minus 2. So what we can say here is we can keep all above the x-axis. We can delete everything below the x-axis, and then we reflect about the x-axis.